So this is part of my series on how CA Technologies helps customers with digital transformation. And in this section I am talking about DevOps. DevOps, one of those terms that we see a lot of fragmentation in terms of definitions. So I'm going to begin by attempting to give a distilled version of DevOps back to first principles. So DevOps has its origins in companies like these guys. You've got Amazon, who do software deployments up to 1,000 times per hour. You've got Google, who run over 75 million automated test cases every day. So these guys are masters of straight-through continuous delivery. They've set up DevOps benchmark in the marketplace. Now, of course, CA Technologies tend not to work with software startups. Our customers tend to be large, legacy-laden organizations who've got legacy hardware, processes, and software, and find it more of a challenge to adopt DevOps practices. So I've stolen this slide from a conference back in 2009. This slide was done by two guys from Flickr who gave a presentation on how they were doing 10 deployments per day, which at the time was groundbreaking. And they used these two popular personas to represent a contentious issue that they were observing at Flickr as a result of these frequent releases. So you've got the likes of Spock, who represented the development community. Developers want constant change, they want the freedom to do frequent releases. And on the other hand, you've got Scotty, poor old Scotty back in the engine room, who just wants to keep the engines running and is kind of struggling to keep up with the increased demand from development. Now, of course, it's not just about developers and testers, but there are stakeholders throughout the software delivery lifecycle who have an interest in DevOps. Not least of which is the line of business executive, who ultimately wants the IT to deliver software faster to ensure competitive advantage. Now, this book is one that I refer back to kind of as a DevOps Bible. The author, Gene Kim, released this book a few years ago, and in this book he outlines 3 principles of DevOps. So the first is flow, and this is all about system thinking, because traditionally, with waterfall approaches to software delivery, you tended to have siloed thinking. You had developers who worked in isolation, testers who worked in isolation, and operations who worked in isolation. So flow is all about system thinking. How do we increase the throughput of software delivery through these different sort of silos? Feedback is about providing feedback from production, so the likes of production telemetry, and making it available to developers and testers. It's important that developers and testers can have a dashboard into how the software is performing in front of users. Continual experimentation is the notion of playing with failure in a non-prod environment. Now, this is a pretty elusive thing to do. It's quite difficult to recreate production-like scenarios in a non-production environment, but this is important to do. You either play with failure in your non-prod environment, or you let your customers play with failure. So obvious which we want to achieve. So CA Technologies has a suite of technology around continuous delivery. Continuous delivery is essentially about improving the throughput of software. Now, there is a notion in DevOps of cycle time, and cycle time is a measure of how long it takes to get a software change through the complete software delivery lifecycle. So a software change could refer to a complete new software product. It could refer to an update to an existing product, or it could be a bug fix. But in whichever case, the cycle time is often measured in months or years due to sort of fundamental constraints and challenges in the software delivery lifecycle. So if we look at some of the typical software delivery stages, it begins to become apparent where these challenges are. So for example, in development, we often find that developers work in isolation. They'll be working on a single component and they won't have access to back-end systems, so they will be working in isolation. They will also face test data constraints. They may not have access to all of the test data that they would need to go through basic test cases. Developers often use continuous integration like Jenkins, which is a great help. This gives them continuous integration capabilities, but that does not mean that you've got continuous delivery. Continuous integration is not DevOps. Testers also face challenges around access to downstream systems. They usually do have access in the form of some test environments, but it's quite often the case that these test environments are unavailable. I worked for one telco in India where there was a room full of testers who were idle for over 50% of the time, and this was due to unavailable testing environments. We also see an overdependence on manual testing. So manual testing ideally should be reserved just for exploratory testing. If you have regression tests or any sort of repeatable tests, they should be automated. System integration testing. Now, the intention of SIT is that this is for testing connectivity. Now, typically, SIT is where you bundle an end-to-end environment together and allow integration testing. Unfortunately, SIT tends to take much longer than expected because you end up finding basic defects. Why? Because this is the opportunity to go through some basic test cases because it is an end-to-end environment. By example, I worked for a credit card company who had SIT scheduled for 6 weeks, and they frequently had SIT cycles going on over a year simply because it was the first opportunity to test end-to-end cases, and therefore they found a lot of defects that had not surfaced before. Now, performance testing brings another set of challenges all by itself. Obviously, environment availability is a challenge for performance testing. So, think about this. You're running a performance test, so you're ultimately trying to put production type throughputs through your non-prod environment. So you're going to have to scale up your environments to handle production levels of throughput. Now, that's a challenge to do. It's not easy to set up that kind of scale of environments. Another challenge with performance testing is how do you test realistic production scenarios? Another example, I worked with a performance testing team for a large worldwide bank, and they faced a challenge whereby they needed to capture the slow performance of a mainframe between the hours of 2 and 3 p.m. every day. So the performance testing team was based in the UK, the mainframe was hosted in the US, and the challenge they faced was that, when US citizens woke up and began transacting against the mainframe, it slowed down. So the performance testing team back in the UK had to wait for that period to begin their performance testing, because otherwise they would have had they wouldn't have been able to cater for those mainframe response times. So these are examples of challenges that we see in non-production environments. The ultimate result, or the outcome of this, is that you rely on your customers to complete the testing, which is obviously not what we desire. So how do CA technologies help with this? Well, to begin with, we have Agile Requirements Designer. Now, the questions that this addresses are you testing everything that you should be testing? Are some of your test cases redundant? And if you make a change to your system, how do you know the impacts of this change on your test suite? Now, some of you may have seen this graphic. I saw it, I think, about 20 years ago when I was in development. It made me laugh out loud because it was so true. And unfortunately, I think it's still true. Now, what this cartoon brilliantly captures is the siloed nature of software development. So stakeholders belong in different camps, and there's no flow of communication between them. So software development is managed by a form of Chinese whispers. And the results speak for themselves in this cartoon. So Agile Requirements Designer allows us to map requirements and user stories to unambiguous active flowcharts. Now, flowcharts are a very useful medium because they're kind of a universal medium between business analysts and technical community. Everybody can understand them. Business analysts can make changes to them, and from these we can generate the necessary test cases. So once the requirements have been captured in these flowcharts, Agile Requirements Designer can automatically create the minimum number of test cases to support that requirement with the maximum test coverage. So from your requirements, you generate the test cases rather than relying on human effort to figure which test cases should be used. Another nice aspect of Agile Requirements Designer is it allows you to measure the impact of any change. So, a butterfly flaps its wings and a hurricane is triggered the other side of the world, cause and effect, etc. When you make a change to a requirement, what is the impact of that change on your test cases? How do you know which test cases are now redundant and which need to be changed? Agile Requirements Designer allows you to identify the impacted test cases and can even update automatically the test cases that have been affected. Now, Agile Requirements Designer feeds into CA Service Virtualization. Some of you may have come across this capability before, but it's ultimately about helping developers and testers. So let's assume that we have a development team working on this highlighted component. Of course, in order to do any useful development or testing, they also need access to downstream systems like the app server, the ESB, the backend mainframe, etc. And the challenge is, of course, they won't have access to these. So the idea of virtual services is that you create something that is synthetic, that takes the place of these downstream systems. So in effect, it gives you 24/7 access to a downstream environment that you would otherwise not have access to. Or if we're working on the ESB, again, you're focusing your development or testing efforts on the ESB, but therefore you need downstream systems like the ERP system, like the mainframe. You also need upstream systems which feed messages into that, and you will not have access to these systems. So with service virtualization, we can generate synthetic versions of upstream and downstream systems to effectively give you, again, a complete testing rig that you've got 24/7 access to. Now, the impact of service virtualization on the delivery schedule, well, it's the difference between working in serial and working in parallel. With service virtualization, you remove constraints and you allow development teams and testers to work in parallel rather than sequentially. I mean, this slide is taken from a real-life customer who monitored the difference that service virtualization made on a 10-week value release cycle. Some of the highlights, they found nearly 4 times as many defects. Why would that be? Well, they had access to test environments that previously were unavailable most of the time. CA Service Virtualization is recognized very much as the leader in the space of service virtualization. Now, another capability that links with Agile Requirements Designer is Test Data Manager. So Test Data Manager addresses some constraints that we have all faced with test data management. The traditional approach to test data requirements tends to have been, let's take a copy of production data. And of course there are challenges with this. There is risk in terms of that data may contain sensitive customer information, PII or PCI DES in the financial services sector. And with regulations that are coming into play, certainly in Europe with GDPR, these practices will be outlawed. But even apart from the risk factors, it's slow working with production data. And the production data tends to get stale and out of date very quickly. It's also ineffective. You don't necessarily get good test coverage with production data. So what testers really want from test data is they want quality data, data that gives them maximum test coverage. They want efficient test data. So it's no good having a Teradata kind of a data warehouse which contains lots of duplicate records. You want the minimum footprint of test data with maximum test coverage. You also want test data that is safe, guaranteed safe to use, perhaps for offshore development or testing teams. So we want assurance that this does not contain sensitive information. And crucially, we want this available to be, or we want this data to be available. It's got to be fast to provision. It's got to be, we don't want contention issues. We don't want one tester burning another tester's data. So this is essentially what CA Test Data Manager provides. We've got the ability to take production data, to subset it, meaning that we get the same test coverage in a much smaller footprint. We can desensitize that data, so where there is sensitive information, we can replace that with obfuscated data. We can also do synthetic data creation. So rather than desensitizing existing data, we can actually create new test data. And crucially, we can provide test data on demand. So give testers the ability to request data that fulfills their needs and have it available when they need it. Now the benefits of CA Test Data Manager outlined here with many real-life customers, but ultimately you're talking about massive efficiency gains. Now release automation. Release automation is effectively about managing the process of software delivery throughout the environments. Now we know from surveys that most application failures are due to configuration errors in releases. And we know that release bottlenecks occur when you have an allocated release window, but long release times mean that you miss that window or perhaps take longer than allocated. We also know from surveys that IT operations teams spend a lot of their time on releases. So think about releases not just into production, but a release could be from development to testing, from testing to SIT, from SIT to performance, or of course from non-production into production. So what CA release automation is about is effectively putting in place a conveyor belt to manage this software delivery process. How it works, we define what the application is in an abstract sense. So think of a three-tiered application. It may have a web layer, it'll have a content, business logic, it'll have a database tier. The application may also be configured with additional components for application server, or other aspects. But essentially we define what the application looks like on an abstract level, define the components. We also define the where. So this refers to the different environments this software is going to be deployed to. So think about different environments. Your dev environment is going to look very different to your performance testing environment. In performance testing, you're going to have horizontal scalability, you'll have load balancers, etc. So the different environments look very different. So you've got to define the attributes of the environments. The how represents the workflows, how we get the software between these different environments. So this is the work processes to automate the transfer and configuration changes to get software into each of these environments. Now, as part of these workflows, we will also be interested in quality checks. So running automated tests, and if a test fails, perhaps implementing a rollback mechanism. This is all part of the how. In terms of who, we are interested in who's got access to reports and management information dashboards that come with the release automation products, but also who is allowed to instigate the releases. And the when refers to when we kick off release schedules. So it may be automated, it may be as a result of a Jenkins continuous integration build that we pick up on that and orchestrate the rest of continuous delivery workflow, or it could be a manual process somebody kicks off through a dashboard. Now the results of release automation, some of them are documented here. These are real world customer results from a variety of customers, and the benefits are, frankly, they look unbelievable. You're talking about from 2 days down to 3 minutes. But this is in fact the benefit of automating what would otherwise be horribly complex manual processes involving many SMEs.